Glenn Condren and David Fowler, and they're going to discuss developing and deploying microservices with Thai.
Yeah, hello everybody.
Hello.
Thank you for the introduction. Let's jump straight into some slides here, right? So we have, we already said, I'm Glenn, this is David. And
Yep. Hey.
What we're going to talk about today is, you saw the keynote. You saw Fowler do the get started, here's the front end, here's the back end with Thai. And so what we really wanted to do, hopefully you saw it. If not, just go, if you're not, tell me now, we'll just stop, we'll wait, go watch the keynote, come back, we'll wait for you, okay? So as you saw, what we really wanted to do here though was focus on stuff that we hadn't talked about before much at all, and also talk a lot about some of the data and learnings that we've gotten from the Thai experiment. So there's going to be a lot of that, and not so much of an introduction to Thai, just so everyone knows what they're getting. And I've put some links here into other talks where we talk about a lot of stuff. And also tomorrow, there's a talk by John Gallant from the Azure team where he uses Thai with a whole to be honest, a ridiculous amount of stuff. So you should go watch that as well if you're interested in Thai at .NET Conf tomorrow. Okay, so first, why did we start this Thai thing? What was our goal? What were we trying to achieve? And did we achieve it over the course of the .NET 5 experiment? So we came into this wanting to flatten the learning curve for people who are using .NET and trying to build microservices and deploy to Kubernetes. So what we looked at what it took to get to Kubernetes and said, that's a lot, right? And not so much that's a lot in that this is overwhelmingly hard to learn ever. More in, okay, if I need to understand what this cloud native thing is or what this Kubernetes thing is, let me just try and build a basic app and get it up and running. You needed a lot of upfront learning before you could get anywhere. And so Thai was really trying to flatten that out, let you get far further before you had to learn about anything, maybe make some stuff disappear, but then help you learn and then bring in those extra tools as you want. So things like Docker becomes optional, Docker Compose, Kubernetes manifests, things like Scaffold Helm, all those stuff become things you can grow into instead of being basically requirements on day one. That's what we're trying to achieve. Turns out, as we went, we kind of developed a lot of stuff that was really useful when you weren't doing Kubernetes and microservices, but we'll talk about that a bit more as we're trying to go. So why was it an experiment? Well, I kind of said this a minute ago, which was not even a minute ago, which was, turns out a lot of our stuff wasn't just useful when we were doing Kubernetes and microservices. By doing an experiment, we are trying to learn as much as possible about a space, understand as much as possible about a space, and develop things in the open and gain feedback without putting it into the box, right? By putting something into, say, the .NET SDK or into Visual Studio, we're shipping it. It's out there. And if it was wrong or we were going down the wrong path or it turns out that was not quite correct, let's say the Thai YAML format is bad for some reason that we haven't worked out yet because we're not deep enough in the space, and then we want to go change it. If we've shipped, that destroys the world, right? So we want to reserve our ability to act fast, to be agile, and more importantly, give everybody the right idea about what we're doing, which is really learning. Experiments are about learning. They're about understanding, right? And they're deeply engaged with, and we try to deeply engage with everybody who uses Thai via our survey and via GitHub and via talking to people. We spend a lot of time just emailing, calling people who have used Thai. Fowler and I personally do it a lot. So the Thai survey, if you haven't done it yet, this is a link. It's in the dashboard if you ever try out Thai and you do the dashboard. When you do try out Thai, if you haven't yet, click this link, go do the survey for us. If you're okay with us reaching out, do know that we do that.
We'll call you.
We'll call you and we'll say, what did you do with Thai? Talk to us about your experience. We'll spend half an hour on the phone and say hey, I just dated myself by calling it a phone, I suppose. And so just find out what you've been doing to try and learn more about how Thai should be adapting to fit what people are trying to do. So let's jump into what did we actually learn from the survey and from the Thai experiment. Well, the first thing that we wanted to try and learn via this survey was how many microservices or services in general are people kind of doing today. If you're interested in Thai, how much stuff do you have? And the reason that's critical is because if everybody in .NET land who was doing we're running this type of app, building this type of app today has 400 services. Chances of being able to run enough services to do something really good on one single dev machine is actually pretty small. So the feature set that Thai needs to evolve to support that type of use case is very different to the feature set Thai needs to be able to support the 1 to 10 or 15 set. Turns out, generally, everybody who we've talked to is in the 1 to kind of 15 range, which is kind of achievable on a local dev machine, which gives us a very interesting focus. We can talk about, we now have some idea of what people are. And this has been fairly consistent. I forgot to add in the last slide, our surveys, all the data disappears after 30 days. So if you fill in the survey after 30 days, that just automatically goes away. And so this is the latest 30-day snapshot. And the shape is roughly the same, but the numbers kind of shift depending upon who's been using it. But they still relatively stay the same, which tells us that there's a consistent kind of message coming, at least for all the pictures that we're showing you here. The secondary piece of data that we have here is that we wanted to kind of measure the polyglotness of people who are in .NET doing microservices. Theoretically, one of the benefits you get out of microservices is kind of best tech for the job. Pick .NET where it makes sense to use .NET, pick JavaScript where it makes sense to use JavaScript, and so on and so forth. And so we wanted to get a feel for how much people were already doing that. And it turns out that most of the .NET people we've talked to were polyglot-ish, right? Effectively, this is from a different survey I ran earlier in the year on Twitter. I got a 300 odd respondents. Big chunk of people using JavaScript today with their .NET applications, just as the previous chart showed. Lots of people interested in Python, not so much using it yet. And so that kind of told us, oh, okay, so people today are probably building JavaScript front ends, and maybe they have something that Python is particularly suited for on the horizon. Maybe it's a data processing thing or a ML
machine learning, ML
thing. Something like that, right? We don't actually know because we have hypotheses, which is what I just described, but I can't say that we know because that's the whole point of doing these experiments and this customer development the way we do it is to test, do we know these things? A very common refrain that Fowler and I now ask ourselves is, how do we know that thing that we just said? To try and make sure that everything is grounded. Once you use this type of data and spend a lot of time doing customer development to kind of make yourself more confident in the products you're trying to ship, it becomes very addictive. So polyglot-ish, probably JavaScript front ends, probably some Python. That kind of means that Thai should have at least some escape hatches for some of these other languages, probably, if we really want to support where people are today. And then another interesting thing, and that was potentially surprising, was basically no one was actually doing the Kubernetes bit. Like this one's a little bit more exaggerated than usual. It's normally about 70 to 80%, but it's still really high. Like most people who try Thai do not do Thai deploy. They do all the dev loop stuff of Thai. They don't push to Kubernetes. And we have a few hypotheses for why that might be, and we're testing them out now. We're talking via testing them out via asking people, basically, why you didn't deploy. And we're going through that process to try and understand more deeply. Is it a mismatch of product in that the feature set that we have is bad? Is it a mismatch of target? People don't want to go to Kubernetes. Is it that they're not doing microservices? They just want Thai for something else, and they're going to go deploy to Azure App Service or like some other service somewhere else or on-prem in IIS? We're trying to test all of that to work out what the right mix for Thai is. Right? All of which would have been much more difficult if we had just shipped Thai at the very beginning rather than trying to experiment in the open and get more feedback and let's find out what people want. We also collect anecdotes and tweets and stuff from people. We have good and bad. We know we have lots of work to do in Thai, but we also have lots of promise. And in general, I think if I was to sum it up, it would be via a slide like this, which is generally everybody is really satisfied who really likes Thai. Normally we've got a couple of detractors. This one was actually conveniently really amazing this month. So generally everybody's loving it. So we're onto something. Right, we know there's something there. We know the something is probably mostly in the dev half, the dev in a loop half of Thai, because people are using that and not using the deploy part. But we don't yet necessarily understand why they're not using the deploy part, and maybe we just need more work there. And that's kind of our state of understanding of where everything is. And so for the rest of this talk, what I'm going to try and do is we're going to try and give you a big list set of demos. And we can switch over. In fact, we can switch over to David's screen now whilst I introduce this. We're going to set up a set of demos now, and we're going to go through as many as we can, and then Fowler and I are going to do kind of after setting up the demo list for this talk, we realize it's way too much for 1 half-an-hour session. So we're giving you a set of this. We're giving you this top few. We'll probably get up to about health checks, and then we're gonna make a point of either live streaming or pre-recording a deep dive into all the rest of this stuff after .NET Conf, and we'll let you all know on Twitter if you follow us.
Yep.
And so, with no further ado, take it away.
Is this size good? Can everyone see that? That's good, right?
Let me look at my
Glenn,
stream.
is that
Let me look at my
pretty
stream
good
on the TV. Yeah.
Let me assume it's good.
Yeah. Okay.
So in the keynote, we showed a super simple front end, back end demo.
Yep.
And I kind of want to show that again for those who missed it. Not all of it, but just kind of the main points. So Thai, one of the main purposes was to have it work without having to install too many tools. So you install just Thai, not Docker, not Kubernetes, nothing else. And I can Thai run the application, right? So I can Thai run this application from scratch with just a solution file, no manifest, and it just works.
Yeah.
Just works, kind of.
Just keep running.
So slow?
It'll work eventually.
It's slow. Okay, slow, but it's fine. And in the talk, I showed this dashboard.
Yeah.
So it gives you this beautiful dashboard that will load at some point. Let me.
Yeah.
Probably
Written
slow.
with Blazor.
Written actually in server-side Blazor, which is an interesting fact.
Yeah.
And it shows you replicas, the number of restarts, logs, these things. But we also have this never before seen by anyone besides the people on this call. This new super fancy extension into VS Code.
Look at it.
And the icon is super descriptive.
Yeah. I have no
Thai Explorer. I know. Good job, Glenn.
Hey, they're gonna help you. Yeah, like this looks amazing. Whoever worked on that must be a genius.
The Thai Explorer gives me some tooling I can use to do various operations on my Thai application. So this application is running in the front and the back end. I can see my services. I can see the logs for each service here, right in the IDE. I can see replicas. So this is the service, and this is a replica for that service. I can have several of these.
Yeah.
I can browse to the actual project and application, see it running. That's the back end.
Yeah.
I can browse to the front end. I can attach the debugger. It's pretty cool. And I can even link to the dashboard. So this is the kind of experience we want to build with Thai. Right now, Thai is a command line tool.
You can thank Hunter for that dashboard link.
So today it's a command line tool mainly, but we want to actually have an experience in both VS Code and full VS as well.
Yeah. So I've been working on this. We'll probably get it out to try soon, but not like probably not ready for prime time until we kind of have more of a VS sort of side of it as well. Right now, we do this as an experiment of what we could do, and I'll get it out there so you can try it. But we don't really want to put something out there to get everybody to use till we have both VS and VS Code. Correct.
And super quickly, I can actually hit this URL in the dashboard, API v1.
Yeah.
And it powers, this experience is what actually powers the tools like what VS Code has.
Yep.
The API here actually gives you all the services with descriptions and different operations I can use to look at information about environment variables, replicas, process ID, etc. So we plan to build the tooling on
the VS tooling just uses this API. It doesn't have any special knowledge.
Yep. So it's pretty cool and flexible.
Yeah.
All right. So that's pretty simple. But under the covers, Thai actually does create.
How dare you?
I know. Under the covers, Thai actually creates a manifest file internally, right?
Yeah. In order to it looks at the solution and says, okay, what would a Thai manifest look for this, right? Conceptually.
So it models your application, your solution as a bunch of services. I can actually use Tynet to specify, very specific things about the application if I want more control. So for example, this app has 2 services, and we infer things like if this application is ASP.NET Core, we'll bind 2 ports for HTTP and HTTPS. So we can detect the kind of application based on the project file, MS build or not, and do those kind of things.
So you want one of these files because you can add extra stuff in here where you don't need it if you don't have extra dependencies. But if you want to use Redis or SQL or something, rather than installing it on your dev machine, you do what Fowler's doing right now.
So I can add, for example, a container dependency by saying I want my service of Redis type to be image, to be an image Redis.
Yeah.
I can do project, image, Docker file, executable. So I can run different kinds of things. I can orchestrate a process with a container, with the Docker file.
So that power of the like service definitions being kind of polymorphic allows you to gives you the escape hatch, right? You could build some other language's tech into a Docker image and run it in here and have it participate in service discovery. You could execute like npm run or something for your JavaScript app. This is kind of how one of how our escape hatches are for what we call an escape hatch to let you kind of go do something else.
No, so this could be like cdev, foo.exe.
Also, right? Because this sometimes causes confusion. There's nothing special about Redis. We just use it all the time as an example. It's just any image from any Docker registry will work in the image.
Just tell you around this now. So we support projects, images. If you don't have the image locally, it'll pull it down. It basically lets you orchestrate containers and a process in the same microservice.
Yeah. So
you can see it's pulling.
If we click the whale.
The whale.
There.
And refresh the containers.
Yeah. So now you see Redis has launched in here, right? You can see it running. This is just normal Docker tooling in the Docker Tools extension, right? So we booted up the container. We've also booted up these other two containers here. See how they have called backend proxy and frontend proxy? What they're doing is when you add a container to your Thai dependencies, we spin up these proxies so that if for any reason your container needs to talk to either the front end or the back end, say because it's an app and it's participating in your solution, Redis wouldn't do this, but something else might.
Right.
You can just use normal Docker DNS name resolution, and these proxies take care of resolving that to the actual URL on your local host. So you can run a Docker image, have that Docker image just call front end,
for example,
as a DNS name, and then these proxy containers take care of finding out what the local host URI is and redirecting it to that, such that you can access it normally. So everything can participate, regardless of whether it's a container or a project or whatever. Super cool feature that I'm not sure we've ever talked about before, but it's really nice.
Yeah, it's funny. So if you look here, you'll see this Thai network. Thai will create a network for your containers so they can all talk. So it tries to basically make your application run in its own network. So you can actually send data between your container and your services easily.
Thai kind of pretends to be like this little pretends to be an orchestrator, right? Like Kubernetes is an orchestrator.
It's a fakestrator.
Yeah, fakestrator. I like it. Yeah,
that's
We should coin that term.
We should rename it.
Yeah, we got to rename it now. The fakestrator just gives you just enough Kubernetes-like features to get your dev to be closer to Kubernetes without actually being something like Kubernetes, like Minikube or something like that, where you run Kubernetes locally.
That's right.
Because that's big and heavy and also requires you to be containerized, and that gets in the way of things like just attaching a debugger or something like that.
Right. The goal of Type being we want to ease you into the whole container thing, so you can start with a process and use containers if you want to, and then go to the full swing to Kubernetes if you want to.
An example of where that can be super interesting is, let's say you only want to run the backend plus Redis, and then you're just going to open the front end in Visual Studio and dev it like you've been deving forever. How do you do it?
Super simple. I delete the front end project, right?
Commenting out code the way it's
commenting out things. No, I could add what we call a tag. I could say tags. Right. So I can say I want a backend tag for Redis and a backend tag for the backend project, and I can run tags be.
Nice. Yeah.
That'll run a subset of the containers. All right, locally. So if I refresh this awesome extension, it should show me just backend and Redis.
Yeah, and now you could, for example, spin up the front end in Visual Studio without any knowledge of Thai. Just press F5, debug it, and have it connect still to the backends.
To the backend. That's right. Right. So super useful. Tags let you run a subset of the services locally for your application. All right. So we got tags. We got fronts and backends.
Do you want to continue on the fakestrator features?
Let's try deleting this container and showing some other features. So here I can add things like environment variables. So let's say I want to add a configuration that says foo equals bar.
Of course. Classic
engineers, so that's all we name things, right? Foo and bar.
Yeah,
I can inject environment variables, which is super lame, but it's a cool demo. The front end has an endpoint that I'll show in a minute, where we can dump all configuration and see how this ends up in the actual process.
Yeah.
So this runs. I can refresh. Here again, open the front end.
Refresh was automatic, wouldn't it?
Wouldn't it be? Yeah, you should actually fix this thing to use Signaler. That'd be much better.
Yeah.
I can launch front end.
If only we had a real-time communication framework.
Exactly. Launch run config, and this is actually a new API that we added in .NET. What version is it? 5? I'm not even sure.
Was it 5 or 3.1?
Let's call it 5 because we're doing the conference.
Yeah.
Added in .NET 5, where I can actually dump the configuration hierarchy, and it will show me every configuration setting, and it shows me where it came from. So JSON, environment variable, etc. I can search for foo equals here, and you can see the environment variable that got injected by Ty.
Yeah.
So you can use Ty to kind of to replicate what you would do in production or in dev by passing environment variables per service, and those flow like normal.
Yeah, this is kind of not, and this is not tied to Ty in any way. There's just an extension method on config. You can call it, and it generated this format. And Fowler added an endpoint to his app where he just calls that method. So, and
if you look at the actual application, look at the front end application.
Yeah.
You'll see it has this method here, get debug view, and this is actually the method that we added.
Yeah.
But it also has a health check. So here's my health checks endpoint, and it uses the built-in health checks feature. So I can actually write an iHealth check, and then whenever somebody asks for health, it'll run through health.
The appropriate name for a health check endpoint.
It'll check for my health. It'll call into my health checks and call check health, right?
Yeah.
So I can implement things that are complicated or not to check for my database being up.
So the idea here is, you can either check whether you're ready by running code to see where can I access my dependencies, and you can run checks to see, am I still healthy? And so Kubernetes has a concept of aliveness or a readiness, where am I still alive? Am I ready to receive traffic? And am I still alive? Are two different things.
Right.
And we've mimicked that in the Ty YAML for the Fakestrator that we just named.
Exactly. So I can actually copy this into my Ty YAML for the front end project. These things that are really hard to replicate locally without running a full orchestrator, Ty does just enough to make sure you can actually test these scenarios.
Yeah.
Test your health check. Health Z.
Yeah.
Health Z. Right. Yeah. So I can put that in there, and Ty will actually do the right thing and wait for the app to be healthy by pinging that endpoint, making sure it's running. And that's really cool for testing your health checks locally to make sure that they work without having to deploy to the real environment to test things out.
Yeah. And then when you do deploy, they become Kubernetes health probes, obviously.
That's right.
So Kubernetes also then knows to probe those same endpoints.
Right. So it preserves configuration all the way from dev to deployment.
Yeah. So
I can hit the front end. If I look at where is it? Moving to a healthy state, you can see the health check actually happened. So that's cool. So we got health checks. Environment variables, tags. Let's try another thing that's hard to test when you're developing locally. Replicas.
Yeah. So what do you do when you've got a bug that only reproduces when there's 3 instances running because you use that nasty word?
3 or 2.
State.
I'd hope it happens with 2 as well.
I mean, multi-threading has taught me that there are no guarantees.
So imagine you had some code that was caching something in memory, and then you ran it with 2 replicas. Doing this locally is really hard because it requires you have to pick random ports for each replica, and then you have to somehow proxy traffic across replicas. So Ty tries its best to automate this for you. So when I Ty run, it'll run the application, boot up 2 backends, 1 front end, and it will then proxy data from on a single port across those 2 backend.
And this is just basic round robin, right? So we just load. We will direct all traffic to one of them, and in one after another, right?
Right. So if you look here, you'll see 2 backends and 1 front end with a name that's pretty random. Yeah. And I can actually, using the tooling, I can actually attach to the backend. So let me open up the backend source code here. Put a breakpoint. Look at that.
Look at that.
Did I do this before? Strange. I can attach the debugger here and here.
Yeah, look at that. So now you've
All
attached
good.
to both PIDs and the
That's
back
to both
end.
PIDs.
Yeah. Browse to the front end.
Browse to the front end, and
Drum
then
roll.
cross fingers. Boom!
Whoa, boom! Look at
It
that.
hit some back then. I'm not sure which one it hit, but it is working.
I'm sure you could find out, but yeah.
Yeah.
So then the other one last Fakestrator feature is what happens if one of these processes dies, right? If you look at the dashboard now, another way of viewing this is on the dashboard, right? So if you click that handy dashboard link, thank you, Scott Hunter, for telling us to do that. You see what? We have 2 replicas running, right?
So I have all the backends here running locally, and I can get the process ID for those and kill 6180.
What could possibly go wrong? Nice. And so
Did
now,
it work?
thanks to the magic, yeah, look at that. So now, thanks to the magic of like real-time web apps, of real-life updating Blazor server, the TIE restarted that killed process because it knows it should have 2 replicas as soon as it died for whatever reason. And you'll have logs and stuff of saying as such.
If you look here and I refresh and you stare at this closely, stare right here. Yeah, keep your eyes on this right there.
Don't look away.
It just changed.
Look at that.
It just changed one of them. This one's there before.
Yeah.
And I could attach again to the new instance, hit the front end.
Yeah, and hit
have it all work.
And it's like magic. Just like magic.
So the goal is to give you this power locally without you having to install, Kubernetes or use it. And then if you want to go there, preserve the semantics of the manifest locally, so you can do health checks, replicas, and those features without having to, run your whole orchestrator locally.
Yeah, that's right. It's awesome. Perfect. All right, so I think we're right on
4 minutes left.
We're right on time for questions and such. If we switch back to my slides, the last thing is we're looking at this extension. We said we need VS extension, normal VS integration. We also have some functions work. We have functions locally, which you might see in John's talk. I'm not sure, but you should watch it and find out. We don't deploy yet functions. We're going to work on that. We're also doing an experiment now along with the team that do the Docker tooling and Docker Compose tooling, looking at Compose integration, what we can learn and do there is what we're doing right now. And then then as we go over the course of .NET 6, we work out which parts of TIE get productized. Some of it will, maybe all of it, we don't know. Still working out the plan. And that's it. So now we have questions, and I think someone is going to pop in like magic. Look at that.
Hello.
And then ask questions.
Thank you so much. That was awesome, David and Glenn. We did get some questions here, and we might not have time to go through all of these, so just a reminder to answer those later on as well. And also for those of you that are tuning in, if you get your question asked, you will get a prize. Jamie will send you a gift card for the .NET merch store. So be sure to tweet your questions. Yeah.
So how does tie into deployment of stuff? So the answer there is, so we only really containerize and deploy your .NET stuff. TIE will let you dev with your JS, C++ type stuff via container references or doing executables or anything like that. But we don't try and deploy those containers to the Kubernetes cluster, at least at the moment. And so you would have to work out deploying those yourself, but otherwise we can definitely get them integrated into your dev flow. You can feel happy to have you come talk to us if you think we could or should do something different.
Yeah, I guess I'd say Docker file is kind of the escape hatch.
Yeah.
For
give us a Docker file.
Containerizing stuff. Yeah, exactly.
Yeah.
Cool. So Johan wants to know, can I add a .NET Framework app as a service to TIE for the local development loop?
Fella?
It isn't built in, but with enough effort, I'm sure you can make it work. There's been people that were able to run IS Express with TIE for local dev and run full framework applications. But we haven't had a big demand for it, but I guess if we did, we would look into it.
Look at something, yeah.
Yep.
You could also at a minimum probably do the same thing we just said for other languages as well, right?
Exactly. Launch a process.
Yeah.
Nice. Michael wants to know, why invent another format for TIE? Could it use a Docker Compose subset?
Because the only thing the world needs is yet another format for expressing the same.
We love YAML.
So the reason we started out with not Docker Compose is because, well, first of all, when we started, I don't think Docker Compose's extensibility stuff had started, but we wanted it to be simpler than Docker Compose. And Docker Compose also, if we were literally Docker Compose, you wouldn't be able to run us because Docker Compose is all containerized all the time. So you wouldn't be able to take a Docker Compose that we used because it would be slightly different. That was kind of our initial hesitation. But right now, as I said on that last slide, we are actually investigating exactly that. Like, what would it look like if we use the Docker Compose format? Does it make sense? What integration points exist? Can we use the Docker Compose extensibility? And we'll see how that pans out in the next couple of weeks, and probably over the next few weeks. And we do intend to look at it. My big hesitation, the big thing I don't know yet with that is, one of the Ty's big value props for me is that I'm not containerized all the time. My apps are just apps. And I don't know how much of that we give up by being literally a Docker Compose file, but we'll see.
Awesome. Well, thank you so much again, David and Glenn, for your
problem.
time. That was a great session.